Ever wondered what happens from the moment you press the power button to when your Linux desktop appears? In this video we'll walk through every stage of the Linux boot process, from firmware to the login prompt, with diagrams and real terminal examples. Let's dive in. Today we're breaking down one of the most important, but often misunderstood, parts of your Linux system, BIOS and UEFI. These two tiny pieces of firmware decide how your computer wakes up, how Linux loads, and why modern systems boot faster and more securely. Let's make this super simple. BIOS and UEFI live on your motherboard. They're the very first software that runs when you press the power button. Think of them as the gatekeepers of your computer. They check your hardware, find your storage devices, and decide which operating system to load. Before it even thinks about loading Windows, Linux, or any operating system, it performs a crucial step called POST, the power on self-test. POST is basically the computer's quick health check. The firmware goes through each essential hardware component to make sure everything is working correctly. It checks the CPU to confirm it's responding, it tests the RAM to ensure memory can be read and written, it initializes the graphics system so you can see output on the screen, and it verifies that storage devices like SSDs or hard drives are detected. If any of these critical components fail, the firmware stops the boot process immediately. Instead of loading the OS, it alerts you with beep codes, error messages, or diagnostic LEDs. But if everything passes, the firmware knows the system is healthy and ready to continue. Only then does it move on to the next stage of the boot process. UEFI is completely different, and much smarter. UEFI can actually read file systems. It understands FAT32, and depending on the implementation, sometimes even NTFS or ext4. This means UEFI can open directories, browse files, and load programs, just like a mini operating system. UEFI doesn't look at the first 512 bytes of the disk. Instead, it looks for a special partition called the FE system partition, or especially. This partition is formatted as FAT32 and contains bootloaders as actual files. Next is the bootloader, and this is the component that decides what your system boots into. The two most common bootloaders you'll see on Linux systems are GRUB and systemd boot. The bootloader's job is simple but critical. It lets you choose an operating system, and then it loads the kernel and the initial RAM file system, also known as the Initramfs, into memory. GRUB is the most widely used bootloader. It reads its configuration file, typically located at /boot/grub/grub.cfg, and displays a menu of boot entries. When you select one, GRUB loads the kernel image, usually named VM-Linux, and the Initramfs image, often called initard or Initramfs. Let's do a quick demo. I'll change the GRUB timeout so the menu stays on screen longer. After updating the timeout and regenerating the GRUB configuration, a reboot shows the updated menu. This is how GRUB applies changes. You edit the defaults, rebuild the config, and the bootloader reflects your changes at the next boot. Once GRUB selects and loads the Linux kernel, it performs one final action. GRUB jumps into the kernel's entry point and the kernel takes full control of the system. From this moment onward, the Linux kernel begins its initialization sequence. After GRUB loads the Linux kernel into memory, it jumps to the kernel's entry point. From here, the kernel takes over and performs these steps. Decompresses itself. GRUB loads VM-Linux, compressed. The kernel expands it into VM-Linux so the CPU can execute it. Sets up the CPU and memory. Enables protected, long mode, builds page tables, and installs interrupt handlers. Initializes core subsystems, memory manager, scheduler, timers, early console, the basic OS building blocks. Detects hardware and loads drivers. PCI, USB, disk, network devices. This is the fast DMESG scroll you see. Mounts the root file system, uses Initramfs first, then switches to the real root, ext4, XFS, etc. Starts PID1, init, systemd, user space begins, services start, and Linux becomes fully operational. Before your Linux system even shows a login screen, something powerful is already awake, systemd. It's the brain that decides what starts, when it starts, and how fast your system becomes usable. Systemd is the central manager of your Linux startup process. It doesn't just start services, it organizes them, tracks them, and runs them in parallel for maximum speed. These branches represent the core responsibilities of systemd, networking, logging, and device management. Systemd works through something called units. Each unit is a piece of your system, a service, a device, a mount point, a timer, or even a target. Systemd reads dependencies between these units. If networking must start before SSH, Systemd knows. If logging must start before a service writes logs, Systemd knows. In Systemd, targets define the state your Linux system should reach, from basic command line mode to a full graphical desktop. The multi-user target is where most servers operate, networking online, services running, but no graphical interface. The graphical target builds on top of that, adding your desktop environment and display manager. This workflow shows how Systemd transitions between run levels. Instead of rigid numbers like run level 3 or 5, targets give you flexible, modular states. Once the timeline completes, the system reaches its default target, the mode your machine is configured to boot into. The final step of the Linux boot process, the login screen. After Systemd finishes loading all targets, the system hands control to you. This window represents readiness, every service, every process, every target complete. Now, it's your turn to log in and begin your session. The Linux boot process is a symphony of precision, from BIOS checks to GRUB loading, kernel initialization, Systemd orchestration, and finally, your login screen. Each stage builds on the last, bringing your system to life. This is the full boot flow, the journey from power on to user control. If you found this helpful, like and subscribe. Tell me in the comments, which part of the boot process would you like a deeper dive into? GRUB, Initramfs internals, or Systemd unit files? Thanks for watching.